Dimensions. Objective: to introduce the dimension of a physical quantity and to discuss the dimensional analysis of an equation. Each fundamental quantity is considered to have an independent dimension in physics. 7 fundamental base quantities, namely mass, length, time, temperature, electric current, amount of substance, luminous intensity, are represented with symbols inside the square brackets as shown. Any other derived quantity can be expressed in terms of some combination of these 7 fundamental quantities. For example, volume occupied by an object is given by the product of its length, breadth, and height. All 3 physical quantities have a base dimension as length. Dimensional formula of the volume is L cube. Similarly, speed is defined as distance by time. Distance has length as the base dimension. Hence, dimensional representation of speed is L t power minus 1. The expression, which includes the base quantities and their exponential powers, is known as the dimensional formula of the given physical quantity. In mechanics, most of the dimensions are expressed in terms of mass, length, and time. As volume has 0 dimensions of mass and time, we can rewrite it as m power 0 L cube t power 0. Similarly, speed can be rewritten as m power 0 L t power minus 1. Similarly, m power 0 L t power minus 2 represents the dimensional formula of acceleration. m L raised to minus 3 t power 0 is the dimensional formula of density. Dimensional analysis. In the study of physics, relation between various physical variables is often expressed in the form of an equation or an inequation. Any physically meaningful equation must have the same dimensions on its left and right sides. This property is known as dimensional homogeneity. This law arises out of a simple fact that only those physical quantities can be added or subtracted which have the same dimensions. Suppose displacement of a car moving on a straight line with constant acceleration is expressed with an equation s equals to ut plus half at square. S is displacement, u is initial velocity, a is acceleration, and t is time period. Displacement has dimensional formula m power 0 Lt power 0. U has m power 0 Lt power minus 1. A has m power 0 Lt power minus 2. T has dimension m power 0 L power 0 t. We will neglect dimensionless constants or numbers in the equation while writing its corresponding dimensional equation. You can observe that both the terms on the right-hand side have the dimensions of length. It makes sense that two terms with the same dimensions can get added. Hence, the equation has the same dimensions on both the sides. Law of homogeneity helps us in checking the consistency of an equation when there is some doubt in correctness of the equation. A dimensionally correct equation may or may not be the correct physical equation, but a dimensionally incorrect equation will always be a wrong physical equation.